This is the 18th annual Intelligent Ground Vehicle competition.
And it is an AUVSI, or Association of Unmanned Vehicle Systems International, unmanned ground competition.
TARDAC and Oakland University, we call them the co-hosts of the competition.
This is part of how we see it, part of our robotics strategy at TARDAC. This is growing the future generation of next engineers and scientists. We see the items coming out of here as important to our strategic goals for understanding how robotics can be used in the military.
And obviously one of our best vendors and one of our best partners has been SAIC over the years. SAIC has been a long supporter of what's gone on in robotics. They've been with us almost from the get-go when we started robotics programs in the mid-90s. And they understand, they get it, that looking at what these kids are doing, whether it's in high school or colleges, it's really critical to the future and the well-being of the robotics industry.
This is the premier event in the country for robotics and for the teams across the country and international, for them to come and compete and showcase their talent.
There are a lot of teams from the United States, but there are 2 teams from Canada, 1 team from Japan, 1 team from India, and 1 from Singapore.
This tent here is the pit tent for the IGVC. The teams are preparing their vehicles here, getting them unpacked, doing any modifications or repairs that they need to do.
When the robots arrive at the competition site, they have to put them together to make the robot come alive. That means integrate, test, make sure everything functions working.
Once they have their vehicles together, then they are allowed to go out and practice on some representative courses.
They have to test the vehicle against the course, and they qualify so that they can enter the competition.
So that's what's going on behind me right now. The teams are going out, attempting to qualify, and if they're unsuccessful, then they come back and make whatever changes they need to make in order to qualify. Then when the final day of the competition arrives, they'll go out and compete. We're using a different course they won't have been able to practice on, and the best robot wins.
The competition here challenges the student teams to 4 advanced robotic processes.
The major event in our first event is the Autonomous Challenge, where it's like a vehicle driving down a highway where you and I would negotiate obstacles and follow lit traffic lanes. The robot has to autonomously navigate these traffic lanes and avoid obstacles.
You have to rely on computer vision, and just like a human, you would see lanes and pick up the lanes. But you also have to avoid obstacles, and you have to move as fast as you can around the course.
Our next event is the navigation event, which takes into account GPS, or global positioning system.
In the navigation challenge, the teams are given GPS waypoints in a field that also has obstacles placed in it, and they need to travel from one waypoint to the next in the prescribed order. There's the design challenge, which is what I'm here to judge.
You present your report, you make an oral presentation, and there's a vehicle inspection. And this is where we look at what innovation you've made to this competition.
And they're rated on how creative they are, how much work they went into it, how much value engineering.
The last one is the JAWS, J-A-U-S, stands for Joint Architecture for Unmanned Vehicle System.
Where the vehicles have to demonstrate that they can follow the JAWS standard, which is a standard for interoperability between robot systems within the industry.
And what it is message set, so all robots can communicate using the same common controllers and hardware. So say if my robotic arm breaks and it's JAWS compliant, I can take another JAWS compliant arm and put it on the vehicle and I'll still be able to operate.
You can see it's a lot of fun to see the light bulb come on, so to speak, for the various students when they see truly the value in using the standards, especially because teams have turnover year to year. You have students entering the school, leaving the school, and so teams that adhere to the standards are in a lot better position to pass their knowledge on from year to year as the team members change in and out.
The students are ready to enter the professional field when they walk out of this tent. They can design, they can work as a team, They have system experience, they have field experience, debugging experience. They write, they present. I can't think of much more you need on a resume to get your first engineering or scientist job.
We actually currently have a job opening within my organization at SAIC. So one of the things I'm doing here is talking to prospective employees who are here as students.
I think we've actually hired as many as 5 kids over the last 3 years that actually were involved with IGVC, and we continue to look at that as a source for new talent in our own laboratory.
So we recognize the importance for getting people into this field and gaining skills that they can use and transition and come to work for SAIC.
There's a lot of benefits to SAIC being a part of this. It's an exercise of staying at the very, very leading edge of ground system robotics. That's the first thing. Secondly, it's our ability to interface with the students and the graduating folks that are going to be on the job market soon. And then it's a huge opportunity just to connect with our customer here locally. Any day where you can get out of the office and come be with students and be outdoors with the real robots and other equipment running around is a good day.